Okay, so hello Zuhair, Assalamu alaikum. Am I audible?
Yes, sir.
How are you?
Fine, sir.
Okay, that's great, Zuhair. Could you please switch on your video, Zuhair? Voice lagging. Okay, everyone. So okay, let's start the class. Okay. So basically, we were doing the revision. Okay. So, but from now onwards, we are going to start a new chapter that is the gravitation chapter, right? And this gravitation chapter is basically, or you can say, is the new chapter. Like it is not, you can say, related, relevant to the previous two chapters, like force and laws of motion and motion chapter, right? So this chapter is completely independent, right? The topics that we have done so far, only a little bit concept of force is there that we'll be using, and the equations of motion is there from the motion chapter, right? Otherwise, all the chapters, all the topics are completely independent and new to you. Okay. So okay, sure. So now let's start the chapter with it. So the first topic that we have is the universal law of gravitation, right? So first of all, everyone, let's discuss a little bit about the gravitation first. So gravitation, okay. So we live in a we live on Earth, right? And there is a very big universe, like infinite universe in the outer space. Yes or no, everyone?
Yes, sir.
Yeah.
Yes, sir.
Yes,
So,
sir.
okay, so basically, the universal of gravitation says that if you are sitting in the universe, so every object in the universe is exerting some force on you. Every object in the universe, right? And you are also exerting the same amount of force on the whole universe as well. Like this is the basic thing. It means that each and every object is connected and it is attracted towards each other in this whole universe, right? Suppose that if I'm sitting in New Delhi and someone is sitting in, suppose that in Saudi Arabia, right? So it seems that we are very we have a very massive distance between us, right? But the thing is that in actual, we are basically exerting some amount of force on each other. Maybe it's not observable, maybe it's not like that you can experience that force, but still it is there. That is the gravitational force. It means that each and every body is attracted towards each other. Am I clear to all of you?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Sure. Great. Zuhair, could you please switch on your video? Your video is not visible to me. If you are comfortable with that. Arham and Arhan, I said something to you, bacho. You are continuously switching off your video, even asking again and again. That's not a good thing. At least if I'm continuously asking, so please respect that thing at least. Because that is just for your benefit. Okay. If I can, if I'm able to see you, after that, I will be able to judge that whether you are getting my point or not. If you do not switch on your video, so it will be just like a blank class for you. Okay, that's it. Okay, so here let's write down some points. Okay, one more thing in this, everyone. So basically, we assume that the masses are point mass or spherical masses because these makes our calculation much easier, right? So because if you consider the shape and size in each and everything, so that will lead to very complex calculations. So in ninth standard, that calculations are not, you can say, feasible. So that's why we assume that they are point masses, just like points, see this thing like point, or they are spherical masses. Clear, everyone?
Okay, sir.
Yes, sir.
Okay, that's great. Chalo. Okay, so each and every body is, so just a second. Just before that, let me write down. Opposite center. So this is the force with which Earth tracks the body. It's called gravitational force of Earth. Okay. Called that. Okay. So basically, the gravitational force of Earth is responsible for many phenomena. Like, so basically, you must have seen this thing. Our Earth is basically confined in some space, right? Everything is basically, you can say, as you can say, like attracted. You can say, like it's like that you paste it with something. So it means that if like water on the earth is not like flowing through the whole universe. It's basically confined in a specific region, right? It's only confined in the, you can say, earth atmosphere, right, everyone? So basically this is due to the gravitational force, right? And we are sitting on the surface, that is also due to the gravitational force of the earth. So gravitational force of earth is basically responsible for many phenomena. Like, so let's write down these things as well. The gravitational force of earth responsible holding the atmosphere, right? So this is due to the atmosphere. The atmosphere above the earth, falling of the rain, or flow of water in rivers. Okay. So that is due to the gravitational force of earth. Am I clear to all of you?
Yes, sir.
Sure. Raj. Okay. Okay. So, okay, another phenomena that basically we sit on the surface without any problem. Okay. We do not basically go into the air, like in the gravity, like suppose that on this in this space there is no gravity, so we basically float in the air. But in like in the atmosphere, we basically firmly sit on the earth. So that is due to the gravitational force as well. Okay. Next is force of earth, which keeps us firmly on the ground. Am I clear to all of you? Please let me know.
Yes, sir.
Sure,
Yes.
sure. Okay, now let's talk about the basically some basic points as well. Okay. So basically, according to Newton, every body in the universe attracts each other. Right? Suppose Samya and Bharti are sitting, like Samya is sitting in suppose India, Bharti is sitting in Dubai. So basically, they are very far from each other, but still they are exerting some amount of force on each other due to the universal law of gravitation. There is some attraction between them, right? Suppose Rayan and like I'm in Delhi and Rayan is maybe in Saudi, right? So we have very high, like massive distance between each other, but still there is some force of attraction between us due to the universal law of gravitation, right? That means that each and every body attracts each other, right? Even though they are like separated from like thousands of kilometer distance, right, everyone?
Yes.
Sure. Right. Every object in this universe attracts each other. We can say that every body will like, attract every other object with a certain force. Okay, with a certain force. And that force is called as the gravitational force. Okay, everyone?
Okay, sir.
Yes,
Okay.
sir.
Force to object each other gravity. Right? Sure. Okay, now let's discuss the factors like that basically you can say affect the gravitational force between the two bodies. So if the masses are very huge, if suppose that Earth and Jupiter are there, so the force between the planets, if suppose those bodies would be very massive or very high in magnitude, right? Very large in magnitude. But if the mass are very small, so that force will not be that like will be there, but the force will be very small in magnitude. So it wouldn't like you cannot observe that force. Clear everyone? Okay? So if gravitational force between is very small, if the masses of the ob- if the masses of the bodies are small. Okay? So it cannot be easily observed. Next is that if one of the body is very high, like it have very high mass, like Earth. Like suppose that we like as a person, I have only like 50 to 60 kg, but Earth has like suppose like Earth has 6 into 10 to the power 24 kg of mass. So as compared to Earth, my mass is negligible if we compare the mass of Earth and mine. Yes. So the force between me and the Earth would be not that much high, right? But the Earth force of Earth on me would be visible. Suppose that's why I'm sitting on the Earth, like I'm on the surface. Okay? If one of the body is very large, you can say very big, then gravitational force will become large. And can be seen. Okay? Clear everyone?
Yes, sir.
Yes, sir.
Correct. Yeah. Okay, now let's talk about the gravitation, basically the universal law of gravitation that basically is given by the basically Isaac Newton. So that law says that, so I'm writing this statement here, every body in the universe. So let before that, let me basically tell you. So that's the, as I told you that the masses are basically assumed as the spherical or point masses. So I'm just taking it as a spherical mass. Okay, this spherical mass. Another mass basically is placed over here. Let's suppose Earth. Right? So this is it. So there is some distance between them. They're separated by distance. It could be anything from their center, right? Okay. So that distance is supposed R, and the mass of this body is M. Mass of the body is M2, right? So according to the gravitation, universal law of gravitation given by the Isaac Newton says that every body in universe attracts in every other body. So with a force which is directly proportional to the product masses and inversely proportional. Inversely proportional to the square of distance between them. Okay. So it says that it comes. So it according to this statement that is equals to force is directly proportional to the mass m1 and m2, and force is inversely proportional to the square of the distance between them. Right. It means that if you increase the distance, the force will get decreased by the square of that number. Right. And if you increase the masses, if any of the mass is getting increased, the force will also get increased. So if you combine them now, so that equation comes out to be F is equals to m1 m2 by r square. So if you remove that proportionality sign, so there is a constant. Whenever we remove the proportionality sign, there is a constant involved in the equation. That is your next constant. That is G capital G m1 m2 by r square. Right. So this, let me tell you what is G basically. G is called as the capital G is called as the universal law of gravity. Oh, sorry, universal gravitational constant. Universal gravitational constant. This is okay. And this gravitational constant does not depend on anything. It means that wherever you go in the universe, it will remain constant. It is not going to change at all. It does not depend on mass of the body. It does not depend the distance between anything. It does not depend temperature or any factor pressure or some whatever is there in the universe, physical quantities. So it is not going to affect that constant at all. Okay? So the value of this, so I'm writing the value of G Mhm. Every part of it. Okay. So the next thing about this is basically the value of G is equals to 6.67 into 10 to the power minus 11 Newton meter square per kg square. So this is the SI unit of this constant. Or in some of the questions, or in some time, basically in some of the questions, the value of this G will be given to you as G is equals to 6.7. It basically round off the figure and it is equals to 10 to the power minus 11 Newton meter square by kg square. Newton meter square by kg square. Am I clear to all of you? Please do let me know everyone. Is there anyone who is having doubt till now?
No, sir.
Clear to all of you? Please do let me know.
Yes, sir.
Sure.
Yes.
Great. Okay. So this is the gravitational constant, right? So, so if we basically tell you, if you define, if the question comes in the exam that how will you define the, you can say the G in terms of the force and the mass. So you will say that the gravitational constant is numerically equal to the force of gravitation, which exists between two bodies of unit mass. Unit mass means 1 kg of mass. Unit mass is kept at a unit distance. It means that it is basically they're 1 meter apart. Okay? Kept kept at a unit distance, okay, from each other. So if you basically place, if you basically substitute 1 into 1, so that would be 1 and divided by 1. So everything will become 1. So if you multiply or divide by 1, so it will remain same. So F will become equal to G. It means so that's what the statement is saying, that it is numerically equal to the force of gravitation which exists between two bodies of unit masses kept at a distance from each other. Am I clear?
Yes, sir.
Yes. Is there anyone who is having doubt?
No,
No, sir.
sir.
Yeah. Okay. Sure, that's great. So as you can see this thing, as if you observe this thing that suppose if I'm sitting if everything in the universe attracts each other, so why there is no motion basically between the bodies? because the force of the magnitude of the force is very, very small. So, right. So it will not basically it does not overcome the frictional force on the and the inertial concept. So that's why there is no relative motion between the bodies. Am I clear?
Yes, sir.
Okay. So just various objects in this earth attract one another. Constant. It will not cause same motion because force of attraction between very okay. So that is the reason behind the okay. Let's uh, let's do one portion based on that. So as you can see, the question is saying that calculate the force of gravitation due to Earth on a ball of mass 1 kg, okay, lying on the ground, and everything is given to you, right? So yeah, okay. So I'm going to basically denote the mass of 1 kg as a small m, 1 kg, that m is equals to, and capital mass, capital M is for the mass of Earth, that is 6 into 20 to 20, 6 into 10 to the power 24 kg. Radius of Earth is given to you, that is r. It means that the distance between the object and the Earth, that is 6.4 into 10 to the power 3 kilometer. So kilometer is not the SI unit of the distance. So I'm going to convert it into meter. So that would be 6.4 into 10 to the power 3 into 10 to the power 3 meter. So that would be 10 to the power 6. Yes or no, everyone? So it would be 10 to the power 6 meter, right? And the value of G is given to you as 6.7. So in some questions it would be 6.7, in some question that would be 6.67. So that will vary, but it's almost same. Newton meter square. So so first of all, please check before solving any question. You have to check out whether the values are in SI unit or not, whether the values are matching or not. Sorry, yes. Okay, units are matching or not. So now let's substitute according to the formula, that is F is equals to G M by R square. So I'm going to substitute all over values here. 6.7 into 10 to the power minus 11 into M is your 1 into 6 into 10 to the power 24 divided by 6.4 into 10 to the power 6 square. Am I clear to all of you? Please do let me know, everyone.
Yes, sir. Yes, sir.
Right? Sure. Okay, sure. Now, everyone, you can see this thing that 10 to the power 24 and 20 to the power 11, both bases are same, so we can add them up, right? The powers will get add up. Yes or no, everyone? Exponent law. Okay.
Yes, sir.
So that would be 6.7 into 6 into 10 to the power 24 minus 11. That would be positive 13 divided by 6. If you, so that is square, so 6.4 into 6.4 into here 10 to the power 6. So this is square, basically they're getting squared. So it means that 6 into 2 would be 10 to the power 12. Okay. So as you can see the thing, if I take the 10 to the power 12 in the numerator, so that would become negative. So that is equals to 6.7 into 6 into 10 to the power 13 minus 12. 1 is left over here. Yes or no, everyone? Divided by 6.4 into 6.4. Am I clear to you, everyone? Till now, please do let me.
Yes, sir. Clear. Yes, sir.
So, yes, yes, please let me know. Is there anyone who is having doubt till now?
Yes.
Okay. So that is equals to, that comes out to be 9.8 Newton. This value is coming out to be 9.8 Newton. Okay, if you basically divide it, so this will comes out to be 9.8. Am I clear to all of you? Please do let me know what.
Yes, sir.
Yes, sir.
Anyone having doubt till now, please do let me know once again, everyone.
No, sir.
Who is having internet issue? Is there anyone who is having internet issue? Someone is basically joining and leaving the class again and again. Okay. So that's how you will substitute the values over here and will, okay. So this is how the question will look in the exam. So when the two, so basically you will like if you talk about the human level, that force is not that much visible or not that much strong. But when it comes to the, you can say the universal level, like the planetary bodies, the exoplanets, the stars, the sun, it becomes very, very large, right? Okay. So sun exerts the basically sun and earth are attracted towards each other, right? So basically you can see the sun and the earth a very big body, right? So the force between them would be very large. So that's why sun is able, sorry, earth is able to revolute around the sun. That is the force of attract, the gravitational force of attraction. That's why the sun, sorry, the earth is able to basically complete the revolution around the sun. Am I clear to all of you? So these are the, okay, these are the universal things and these are the phenomena that we observe due to the gravitational forces. Okay? So this seems like very small forces, like but at the actual level, that is the universal level, these forces are very, very important. Okay? The whole universe is basically stable due to this gravitational force. So I'm writing it over here, one step something. When both the objects are very, having large masses, then the gravitational force of attraction between becomes very large. Okay? Extremely large or very large. Am I clear to all of you? Please do let me know once again.
Yes, sir.
Yes, sir.
Right? Okay. So basically, let me write it over here. That is A part. It is the gravitational force which basically keeps the Earth in uniform circular motion. As I've told you in the motion chapter, everyone, that uniform circular motion is the motion in which the basically direction changes only, right? Only the direction changes. And this, okay, centripetal force is the force that basically produces the uniform circular motion, right? So this gravitational force acts as the centripetal force for the uniform circular motion. Am I clear, everyone? Like you don't have to go into that much deep, but I'm telling you the reason behind the revolution of Earth around. Okay. So the gravitational force will act as a centripetal force so that the Earth basically is in uniform circular motion. Okay. So I'm writing it over here. No need to worry. It is the gravitational force between the Sun and the Earth, which keeps the Earth in uniform circular motion around the Sun. Yeah. So another phenomena that we that like is very common. You must have seen that tides in the sea, very huge tides, right? So that water level keeps rising and basically falling. That is also due to the force of gravitation exerted by the moon. So when the moon exerts the force on the earth, that produces the high tides in the oceans and the sea. Okay? And basically that is also a combined part of the sun as well. Okay? So B part is the tides in the sea formed by rising and falling of water level in the sea are due to gravitational force of attraction ठीक है, which moon and sun exert on the water in the sea. ठीक है, water surface by clear to all of you, please do let me know.
Yes, sir, we are clear.
Is there anyone who is having doubt till now in this topic so far?
No, sir.
Are you sure, everyone? Shall I? Okay. So just a moment, everyone. Please do not leave the class. Just allow me a moment. Zuhaib, please stay in the class for the 5 minutes. I just need to discuss something with you after this class. Okay? Because this is your first class, so I just need to get inside some like about your syllabus. Okay? So please do not leave the class. Just stay for the 5 minutes, not more than that.